Welcome. The question before us says, from the sieve analysis result of soil samples from a road construction site shown, determine the following. A. Coefficient of uniformity. B. Coefficient of gradation, or also sometimes called the coefficient of curvature. So we have our sieve openings, and we have our mass retained on each sieve. So we say solution. We are going to arrange it just like this: the sieve openings, the mass retained, then we will account for the cumulative mass retained, and then the percentage passing. So for the cumulative mass retained, we find the cumulative of the mass retained on each sieve. So that is going to be 0, 0 plus 45 will be 45. This is going to be 45 plus 55, which is 100. And then this is going to be 100 plus 84, which is equals to 184. Then this is going to be 184 plus 145, which is 329. You go 329 plus 120 gives us 449. 449 plus 212 gives us 661. 661 plus 50 gives us 711. So that would then be 711 plus 17, which gives you 728. We also find the total of the mass retained, which the sum is going to be 728, and this is our total. So for the percentage passing, we use this formula: cumulative mass retained equals to summation of mass retained minus cumulative mass retained all over total mass retained times 100. So how does this work? Let's say you take the first one. So the percentage passing, when you consider the one that has passed the sieve 4.75, we say it is summation of the mass retained, that's 728, minus the cumulative. The first cumulative there is 0 over total mass 728 times 100, which is equals to 100%. So you consider the second sieve, which is 2.0, and we have 728 minus 45 all over 728 times 100%, which gives us 93.8%, right? So if we also consider the next sieve 0.85, so it's going to be 700 and 100%, 0.85 was 728 minus 45, sorry, 100 minus 100 all over 728 times 100. We are going to get 86.3%. So you continue that way for every of the percentages. You come here, you fill 100, 83.8, 86.3, 74.7, 54.8, 38.3, 9.2, and 2.3, all in percentages. So we will take these values to plot our graph. So this is your semi-logarithmic graph. Your semi-logarithmic graph, this is how it is. So you bring each of those values and plot with the corresponding, the sieve sizes you plot with the corresponding percentage passing. So now we have you see 4.75, and the percentage passing is 100. Let's go back to this. You see 4.75, the percentage passing is 100. So I come here, this is 1, this is going to be, this is 2, this is 3, this is 4, this is 4.7, this line is 4.75. So margin with 100%, this is 100, this is 4.75. So I can mark that point, right? Just like you plot your graph, you mark that point. And so the next is 2.0 and 98.90, 2.0 and 93.8. That's 2.0, 93.8. So we come here, this is 93.8, should be about here. When you are doing it, please use your ruler to get a precise value. This is 93.8, should be somewhere around here. So you trace it down using your ruler, and so we is with sieve opening 2. So like we said, this is 2 already. So 93.8, if I'm correct, if my line is straight, is my line, well, this is going to be 93.8 on 2. I don't have a ruler here. So that is that. And then we have 0.85 matching with 86.3 from the table. We have 0.85 and 86.3. So you go, you fail. 86.3 should be around here, just above 85. So it should be around here. So you take your ruler, you trace it down to 0.85. This is 0.1, right? This is 0.1. This is going to be 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. This is 0.8. So this is going to be our 0.85. So this is going to be our 0.85. This is your 0.85. So you trace it from with the 86 86.3. That's, if you place your ruler, make sure it's straight to each other. I think this is still okay. So we place our point here. So you go to the next point, 0.425, margin with 74.7. 74.7 should just be before 75, just a bit before 75. Just use your discretion or make use of a ruler to divide correctly. So that's 0.425. So if you say this is 0.4, this is 0.425. So this is 0.425, that's 0.425. You just make sure it aligns with the mark on the other end. Using your ruler, trace it just like you plot your graphs, right? So now we have another corresponding point, 0.250 and 54.8. I hope you are following. It's 0.250 and 54.8. 54.8. So 54.8 should just be before 55. So 0.250. This is 0.2. This is 0.25. So this is 0.25. I hope by now you already know how to read it the way I'm reading it. So you place your point here, place your point here to correspond. I think it's a bit lower, but we use a ruler to correct that. So the next point is 0.180 and 38.3. That's 0.180 and 38.3. So 0.180 and 38.3. 38.3 should somewhere around here. Like so 0.180. This is 0.1. This is 0.2, right? This is 0.1. This is um 0.15. This is 0.18. So um matching it with 38.3, I think it aligns at this point. It aligns at this point. When plotting, please use your ruler to check correctly because you are plotting on your own on a paper plot. So um the next point is 0.15. There's your 0.15 and 9.2. That your sieve opening is 0.15 and the percentage passing 9.2. So 0.15, 9.2 should be just around this point, very close to 10. Then 0.9.2 abi and 0.15, sorry, 0.15. So like we established already, this is 0.15. We already established that from trying to get our 0.18 there from the previous point. So this is your point. So we then have 0.075 and 2.3. 2.3 should be just about here. 2.3 should be just about here. And so you merge it with your 0.075. This is 0.075 because this is 0.01, 0.02, 0.0, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.075. So this is 0.75. So you this is our 2.3, right? We just trace it down and this is 0.75. So now you join your points. You join your points. Please, when doing yours, use a French curve so as to get a very smooth curve. So this is this line. So oh my god. So that's what we were able to get. So now you're asked to look for your CC and your CU. So in the formula, CC is D60 over D10, while your CU is D60 over D10 and CC is D30 over D10. And D30 over D10 times D60. So what you are going to do here is, and D10, D30 and D60 are effective distribution, that is the diameter corresponding to 10% finer and 30 and 60 fine percent finer respectively. So you come to your graph to get your D10, you say this is 10%. So the point where 10% corresponds to this curve is this, that's 0. The sieve size there is 0.15. That's 0.15. You say D30 where it intersects with the curve, okay? Where it intersects with the curve, you see where it intersects with the curve, you have to draw a line, a straight line to where it will hit on the sieve size, on the x-axis. Okay, so this is for your D30. Let me clean so we can have space. So let me clean all this so that we can I can so okay, that's okay. Um this is your D10, this is your D30. For your D60, the point where it intersects, this is the point where it intersects. Ideally, I think it should be here if I got that angle correctly. So you trace it down with a straight line, okay, until where it hits on the x-axis. So this is your D60. So you see, let me try to do this, even if it's not straight. You get, this is what we are doing, where it intersects on the curve. So that is it. So that is it. This is your, so now the value for our D10, the value for D10 is 0.15. D10 0.15. Let's put it here. Say D10 equals to 0.15. D30 D30 is 0.1. Our D30 here is, I think, 155. Yeah, that's what it reads. Our D30, yeah, just to say 0.155. So you D30 0.15. Let's round it up to 0.16. Yeah. So our D60 is equals to, let's check the chart. Our D60 is, that's this is 0.1, 0.2, 0.3. Our D60 is 0.3, is 0.30. So if we insert it into this formula, that will be 0.30 over 0.15. What will that be? That will be 1.88 for Cu, and this will be 0.3. Sorry, let me erase that. Yeah, this will be 0.30 square all over, no, 0.16. That will be 0.16. 0.16 all over 0.15 times 0.30 would get our CC to be 0.63. So interpreting our result, it says if Cu is less than 4.0, our answer was 1.88, right? 1.88. So Cu equals to 1.88, which is less than 4.0. So we could conclude that our soil is uniformly graded. So thank you. Please like, share, and subscribe.